Ready to try for do something. Okay, we'll start electric potential. That's the last part of electric fields. We'll start capacitors. So try this question. This is a question I gave at the end of last class. Find the resultant electric field strength due to the two charges on this positive charge here. Formula. I want to start new things today, so let's start. So it says that find the net electric field strength for the positive charge. So a positive charge group, what's the net electric field strength out there, right? So this is more of a mechanics question than an actual charge question, but you can expect something like this, right? So you need to find out what's actually happening at this location here. So this positive charge is going to repel this positive charge that way. This negative charge is going to attract the positive charge this way. And these two together will result in a resultant net force, right? That's how it's supposed to work. So you need to find this, you need to find that, you need to find the angle between them, and then you find the resultant. How do you find this force here? So that's electric field strength, sorry. So E equals to K, which is 8.99 into 10 to the power 9 into Q. Charge is how much? 4 divided by D squared. Distance is 5. So 5 divided by 100 square. This will give you the electric field strength due to the positive charge here. And then similarly, if you want to find the electric field strength due to a negative charge here, same thing again. So you have 8.99 into 10 to the power 9. If you're wondering what's 8.99 into 10 to the power 9, that's actually the electric field strength, the Coulomb's constant, okay? which is 1/4 pi epsilon naught, into the charge here is 10, divided by the separation is 5, divided by 100 squared once again. This will give you the electric field strength because of that. And since electric field strength is a vector, you should be able to find the resultant of these two. So can you tell me what are the values for these? এগুলোর value কত আসছে? Three 3.596 into 10 to the power 13 Newton per coulomb. And what about the electric field strength due to the 4? 1.43 into 10 to the power 13 Newton per coulomb. Right, so these are the values out there. Now this is a purely vectors question. So you have one vector here, you have another vector there. How can we find the angle here? Yeah, exactly. So you know this is 5, you know this is 5, you know this is 10, right? Shouldn't you be able to find that angle using the cosine rule, right? And then 180 minus that will give you this angle here. So কত আসছে? কেউ দেখবে অ্যাঙ্গেলটা? This angle. $180. How is the angle of a triangle 180? What are the other two angles? Yeah, the cosine rule. Yeah, cos a square equals to b square plus c square minus 2ab cos theta. Yeah. You want to kiss it? Yes. How? No, that doesn't matter. These are ratios, right? So you mean I can't have a triangle with 5 centimeter, 5 centimeter, and 10 centimeters? Is that what you're trying to say? How is that even possible? আমার যদি base 10 থাকে, আমি আমার ইচ্ছা মতো এটাকে change করতে পারি until it's 5. Why would that stop me from having a triangle? Wait, we're onto something here. It cannot. Why can't I have a triangle with this dimension? 10 centimeter. I'll actually draw this. So 10 is like I can do any ratio. I can do like 2 and 1 maybe. But 1, 2, 3, 4. 4, আচ্ছা 4. তারপর আমরা এটা 2 সেন্টিমিটার করতে হবে। 2 সেন্টিমিটার পসিবল না? কেমনে পসিবল না দেখি? এই যে হয়তো this is 4 and that is 2 because triangles work on ratios, right? So এটা তো ratio হচ্ছে 2:1. কোনটা? এটা তো হবে। আমি তো ইকুয়ালি চেঞ্জ করতেছি। এটা তো 2 আসছে। না মানে of course I'm like আচ্ছা okay maybe একটু এদিকে যাবে। There you go. But it is possible, right? মানে what you guys are saying that this angle is 180. আচ্ছা I don't know. So এখানে I'm not interested in math triangles, but সবার কি কোনো অ্যানসার আসে না? 180 আসে? Exact 180? What? By the way, those who are wondering, this is not a physics issue. It's a triangle math issue, but I can't agree. So can we actually draw this triangle? No, but it is possible, right? I said that. The impossible triangle. I don't think the. Let me check. Just give me a second, okay? Yeah, I can't. Yeah, well, apparently it's not possible. Yeah, there's a name for this triangle. It's called a degenerate triangle. I didn't know about this. Okay, so I don't know how I ended up drawing a degenerate triangle, but yeah, it's not actually possible. There's a rule in math. না এটা actually perfectly ওই value আসবে না, একটু miss হবে. And the reason behind this is there's this law in math, if you remember, sum of two sides must be always greater than the third. Triangular খুব fundamental rule ছিল, ওটা এখানে broken. Sum of two sides is equal to the third. Okay, so এটা যদি 5, so এটা 5.1 হলে হবে, which is probably what's happening here right now. যেটা draw করছি, maybe it's like 0.1 extra, then it's possible. Okay, anyways, let's assume it's some angle. Okay, I don't know, yeah, 120 degree. Okay, তাহলে কি হবে? Forget these dimensions. আচ্ছা, so আমি তোমাদের dimensions দেই নাই কোশ্চেনে, I gave you this is 60 degree. How much should that be? 120. Okay, so yeah, if you have 1.43 into 10 to the power 13, and this is 3.596 into 10 to the power 13, how do you find resultant of two vectors that are like this? Yeah, you can use parallelogram method, vector triangle, or the cosine ruler modification, right? So which is going to be what? Resultant is going to be a square plus b square plus, right, 2ab cos theta. You can find the resultant of these two, right? Do you remember this formula? There was like a shortcut for resultant. Actually, anyways, we will move on. So we are done with field from this one. Oh, right, yeah. Oh, so that's just an alternate approach. So there are two ways you can do this math, where you take sign, add them, and what should it be? Equal to 0. Or you can ignore signs and just equate the two values. Then doesn't work, right? That's the problem. That's the risk. And that's what some students will do. Because when we say definition of electric field strength being 0, we say that the two fields are equal. And then students will write this one, and they'll equate it. But by mistake, they'll also include the what there, the sign. And in that case, it doubles up actually, because once you take the negative to the other side, it's like you double the value. So yeah, so either you take sign and you just add them. So the logic comes from here. If you remember from O levels, let's say there's a box here with 5 Newton here, and let's say 9 Newton here. How do you find the resultant? Yeah, but actually no. So yeah, and you had them taking what into account? The sign, right? So it's going to be 9 Newton plus, because it's on the other side, I'll put minus 5 Newton. So I'll get like a plus 4 Newton, right? So now what if I subtract them and I also put a sign? That's when it becomes double the effect, right? Oh, why is it plus? The reason why it's a plus here is because we basically derive it using cos 180 minus theta, and that's minus cos theta, and that minus and minus makes it plus. So the derivation is based on the other angle, not the base angle. Okay, so electric field strength done. এখন হচ্ছে we'll wrap the topic up. এখানে হচ্ছে there's one last thing to do. So can you go to page 106 or 105 actually? No, electric field strength, the last part. It's called electric potential. Okay, it is a little tricky. Out of everything that we have done so far, I can say this one is a little challenging. Those are actually manageable. Like gravitational field, it's tricky. If you remember, there was a topic in gravitational field, the gravitational potential, phi, right? It's basically that. But it was only one thing all the time. It was just attraction, right? But now you have repulsion here as well. So things get a little complicated. So to carefully the here. So I'll start from fundamentals here. So this is electric potential. And this electric potential is something that you have actually seen before, way before. It's the V, voltage. Okay, so electric potential essentially means the amount of energy a Coulomb charge carries. That's in a circuit, right? But what's its actual definition and what does it actually mean? So we'll start electric potential first with uniform field, because uniform field, this thing exists. Okay, so what is it with uniform field? So let's say you have one plate here and another plate there. This is a uniform electric field. And can you give me a reminder, what was the equation for a uniform electric field, for electric field strength? No. Yeah, V by D, F by Q, V by D, right? KQ by D square is for what? Non-uniform. So that's not this. Right, so you have your positive terminal there. And on the other side, you have your negative terminal. Right, so there's a field inside this, right? And the field is going to apply force on your charge and everything we have done before, right? But how does energy work here? So let me show you. So let's say we take a charge here and we place it there. And as the charge is allowed to move, we have seen this before, that as the charge is allowed to move, it's a positive charge, by the way, the charge is going to experience what because of the plates here? Attraction from the negative side, right? And with this force that's been experienced right now, will it vary or will it remain constant? Constant. That's the definition of electric field strength in a uniform field. That the force that this particle experiences will be what everywhere? Same. So to me, তোমার charged particle থেকে নিয়ে হচ্ছে যেখানে নিয়ে যাওয়া, right? The force is going to be the same. So we want to find out the work done here. So work done a formula key for like mechanics, force into distance. So if the distance here is D, let's say, right? And the force here is F. How much work would be done if the charge went from the top to the bottom here? Straightforward. Yeah, equals to F into D here. And this is the work being done here. But the thing is, the work done here, it's basically energy coming from some other form, right? Which other form is providing energy here? The electrical energy, right? And it's called the electrical potential energy. So the work done here that you have is equal to the electric potential energy. So electrical potential energy. And this one's formula, we know. What was it? E equals to? No, electrical energy formula. So a topic I did this previously to derive that formula, right? I told you a formula for electrical potential energy. What is it? Or electrical energy? Yes, QV. Remember the QV formula? The definition of voltage, V equals to what? E by Q? E equals to QV, right? So yeah, this is the potential value here. Now, if I want to show the value of energy in this full diagram, right? How would I show it? So there is this thing that we do. We draw lines like this. And the lines that we draw here, they're called equipotential lines. So যেরকম lines থাকে. And I think you can remember we actually had this conversation. যে lines গুলো যেগুলো draw করা হচ্ছে, they all have equal what value? Potential value, right? And potential value মানে হচ্ছে ওদের voltage the same. So let's say this here is 1000 volts. And the one at the bottom is 0, just for simplicity purpose. And I have 1, 2, 3, 4, like 1, 2, 3, 4, 5 gaps out there, right? How can I divide these? Yeah, so it will be 1000 volts, 800 volts, 600 volts, 400 volts, 200 volts, and 0 volts. That's how the potential changes, right? What is the significance of these lines here? So this, I want you to be able to answer. You have seen this before. Can anyone tell me what is the significance of the lines here being equally spaced? Ratio same, correct? But anything else? What does the spacing of the line depend on? Equal strength. Huh? Right. So when we draw equipotential line, it means that every gap is equal amount of energy change. So that means if you go from here to there, the amount of energy change that takes place must be the same as the energy change there, must be the same as the energy change there. And in an equipotential setup where the lines are equally spaced, right? What does that mean? The amount of energy you gain for every gap is going to be how much? Equal, right? This is the diagram that you get for a what kind of a field? This is a diagram for a uniform field. So in a uniform field, you'll find that the gaps here that are equally spaced. So this we have done. Now let me show you what we need to learn. You need to learn what happens if a charge goes from here to there in this direction. How much energy does it gain? Or if the charge goes from, let's say, here to down there, how much energy change takes place? So that's what we need to do. So can you tell me if your charge goes from here, the bottom, to the top there, like that, right? Taking that path, does it gain energy or does it lose energy? That's the first thing that you need to understand. এই যে ব্লু প্যাথটা আমি হাইলাইট করতেছি, এদিক দিয়ে গেলে কি এনার্জি গেইন হয় নাকি লস হয়? Why? Yes. So remember, I told you that if you ever go against the nature, but it naturally, if you go against it, you gain energy. And if you go with the nature, what do? You lose energy, right? So you'll find this charge is gaining energy. Gaining what energy? Electrical potential energy, right? Now, if you let go of it, it'll lose that electrical potential energy and fall back, right? But my question is, how do I find this work done here? A distance of x. So work done, let's call it Q. Work done in moving Q. In moving Q to the top. What should the work done be? Should it be force to constant, right? F. Should it be F into D or F into X, or what should it be? Component of the force. So this is the force. You'll break down the force into component. Okay, and then perpendicular. Yes, this F into D, because the work done will always be what to the force, the parallel distance to the force. Remember, if you take a mass upwards, right, and if you take the mass at an angle on a slope, right, what did you do? You found the vertical height change, not the actual distance taken. However, you're right, you can break it into components as well. Complicated of it too. So you need to know the angle, and then you need to split this one up into two components. One is this way, and the other one is so yeah, these two components. This component is what the force would be, and then you can multiply with x. Okay, you can actually do that. By the way, same answer here actually. Okay, so in this case, it's going to be work done is going to be F into D, since F and D are parallel. Is it clear so far? A idea this is কোনটা F into D যেটা, হ্যাঁ, so তোমার অবজেক্টটা যদি হচ্ছে এখান থেকে এখানে যায়, you are fighting against a force that's that much. This is the force, right? And work is only done when your force and distance are what to each other? Parallel, right? Because the definition of work হচ্ছে the energy transferred when a force is applied parallel to the displacement, right? So if you even though you go like this, right, you're fighting against the force this much. So which vertical distance have you traveled? That. So an example would be if I take a ball from here to there, and if I take a ball from here to there, right? How much GP do each of them gain? Yeah. Because it doesn't matter what path you take, right? How much did you do work against gravity? That matters. Okay. So this. Okay, so based on this, okay, example that I. Right, so you have these two parallel plates here. This at the top is connected to a plus 2000 volt, and this one at the bottom is connected to 0. And the separation of the plates that you have here is 10 centimeters. And there's a charge at this location here, which is a distance of 6 centimeters. The charge has a vertical velocity this way of 2 into 10 to the power 4 meter per second. Find the velocity as the object moves upwards. By the way, this is a negative charge, okay? Find the velocity as the object goes and reaches the plate at the top. Okay, so right, so you can charge Q is 1.6 into 10 to the power minus 19 coulomb, and mass is 1.67 into 10 to the minus, by the way. Our mass হচ্ছে 9.11 into 10 to the power minus 31 kilogram. So you need to find out what is the velocity of this object at this point. এখানে হচ্ছে this is the initial velocity, it's upwards. Right, give it a try. Energy interaction. What if the work is done when the force is parallel to distance, and how does the gain energy by moving against the field? So when you go against the field, you are doing work against the force, and to do work against the force, you must give the system energy. So you're basically giving the system energy to go up because it's naturally supposed to go down. So you're doing work against that force. Question is, what's the velocity when it hits the plate at the top? Find V and Q. Yeah, this is the initial velocity of the particle, 2 into 10 to the 4 meter per second. So you have a charged particle that's going up at 2 into 10 to the power 4 meter per second. What is the velocity when it goes and hits the plate at the top? It was an MCQ from the previous syllabus, taken it. The questions were in AS paper. Velocity. Seven. Possible. Question पे पाशे लिखे दे. Yeah, sure. So how do you do this? What do you do here? So as the charge is going upwards, can you tell me, does it gain energy or lose energy? Gain, right? Because it's going with the field. তাহলে তো নাকি lose energy. আচ্ছা, okay. I'll tell you how to figure out if you gain or lose. I'll give you a table because it's a সবারই problem হয়. If a charged particle is going with the field, right? With the field মানে কি? It's naturally going somewhere and your particle is going in that direction, then it loses energy. And if your particle is supposed to go this way and you want to take it the other way, what does it do? Gain energy. So always remember, whenever a particle goes against its natural motion, it gains energy. If it goes with its natural motion, it loses energy. And how do you remember this? Just think of a ball in gravitational field. When you release the ball, which way does it go? Naturally, downwards. And as the ball goes downwards, does it lose GP or gain GP? Lose, right? But if you want to take the ball against the field, right, it has to gain energy to go against the field, right? Here, a positive charge, a negative charge is going towards a positive plate here. Will it naturally go there, or do you need to force it? Naturally, right? So if it naturally goes there, doesn't it lose energy? So whatever your answer is should be actually what then the value here, lower, right? So এটা is an indicator if you're right or wrong. And then Java math করতে হয়. কি আছে answer? 7 বেড়ে গেছে. How? What do you do? Oh, it's gaining energy. না, তোমার তো velocity এখানে in this case তো বাড়বে. আমাদের isn't my negative charge going to the positive plate? Isn't it experiencing attraction? বাড়বে তো. যদি repulsion হতো তাহলে so এখানে তোমার answer কত আসছে? into 10 to the power 7. আচ্ছা আমি করে দিই. Does anyone have any answer before I start? Okay, so there are two ways of doing this. You can use mechanics. F equals to ma, find acceleration. তারপর v square minus u square equals to 2as. What does the answer করতে পারো, right? But I don't want to do that. I want to use energy here because you're learning energy, right? So this is what you write down. তোমাদের কি মনে আছে? So there were like questions of energy where kinetic energy final equals to kinetic energy plus work done against gravity plus friction করে একটা phrase create করা হয়তো ওই আইডিয়াটা ইউজ করি আমরা. Okay, so using energy interactions, so using energy interaction, can you tell me the final k that I have? Like at the end there's going to be a k, right? The final k should be equal to what? At least minimum the initial k. So initial k, this part is very crucial. Should it be plus or minus electrical energy here? But am I going to lose electrical energy and gain k, or am I going to gain electrical energy and lose k? Yeah, you're going to lose what here? Electrical energy and gain k. How much of electrical energy will you lose? QV. QV is the value, right? So you can have plus electrical energy lost. So I'll put different color here. Electrical energy lost. Achha. Now, what's my final k? Half 9.11 into 10 to the power minus 31 times v square equals what's my initial k? Half into 9.11 into 10 to the power minus 31 into 2 into 10 to the power 4 squared plus QV. Q is how much? 1.6 into 10 to the power minus 19 times this part is a little interesting. You need to find the potential difference. Do you find the potential difference for the whole system or that gap here? The gap, right? So how much is the PD for the gap? ওটা কেমনে বের করবা? 800 আসে? কেমনে করছো? Yes, correct. So how to get the PD here? If 2000 volts is because of a distance of how much? 10 centimeters. Then 4 centimeters will give you a potential difference of X. Unitary method, right? So how much X is? 800 volts. So into 800 volts. So once you do this math, whatever the answer is the answer. Check করো তো কত আসে। Yeah, but the problem is that it already had some gain. So if you did your math right, you're assuming that it's starting from where? 0. So but this already had some K. So we are adding that extra to this. কি করতে চাইছে? আচ্ছা না, কত আসে? 1.67 into 10 to the power 7. Oh, because it's going with the field. Yeah, okay. I'll give you a simple analogy. Think of gravitational potential energy, right? When does an object gain GP? When you go against gravity or with gravity? Against, right? And if you go with gravity, do you lose GP or gain GP? Lose, right? So in this case, it's a negative charge, right? And it's going towards a positive plate. Is it going with the natural force or is it going against the natural force? Yeah, so whenever you go in the direction of the natural force, you lose energy. এটাই আসে answer? Okay, ঠিক আছে। আচ্ছা, আই থিঙ্ক আমি তোমাদেরকে ওই চার্টটা দিয়ে দিই, বিকজ এইটা প্রবলেম হয় যে গেইন না লস হবে। ইটস ইজি বাট একটু টাইম লাগে টু গেট ইউজ টু ইট। So I'll give you like the table that will help you figure this out. হ্যাঁ, রিজনটা হচ্ছে the amount of energy gained was like 10 million and the original energy was 7. So yeah, it was a very small value. I probably realized first because it's only high velocity হয়ে গেছে। Yeah, if you have trouble, try to look at this one, okay? So if you have a positive charge and a positive charge is moving towards that positive charge, what is it going to do? Lose K. So gain in energy is needed to overcome repulsion because you're going against the positive charge, right? So you need energy to overcome repulsion. That's why your energy is going to go down. But when you have a positive charge and a negative charge going towards it, it's naturally going that way. It's falling towards it. So as it falls towards it, it's going to lose energy and gain what in the process? K. So whenever you go towards light charge, right? Since there's a repulsion out there, you have to overcome the repulsion. So you're losing energy and you're losing K in the process. So you slow down, right? But if you're going this way, you're naturally going that way. So the energy that you're losing is getting converted to what? K here. And if you're going away, so what happens here when you have a positive and a positive here? Does it naturally go away? Yes. So that's why it's going to gain K. But if you have a positive and negative here, does the negative naturally go away? No, right? So তোমাকে হচ্ছে কি sorry, it does naturally go away. So as it naturally goes away, it loses K. So these are the 4 combinations out there. So আমি এখন একটা তোমাদেরকে random দেই. The negative will naturally move away directly. No, wait, just a second. Oh no, so my mistake. This is plus, right? I'm letting this positive charge stay here. Which way will it naturally go? away. And if it naturally goes away, it'll gain the energy because it's losing potential energy and gaining K, right? In this case, which way is it supposed to naturally move? Towards, but I'm taking it away, so it's gonna lose energy. That's where the K is lost. Okay. Acha, so I'll give you a very quick, simple question. Okay? It's a matter of practice. You'll never have. I have not found students struggle with this for long. It's just enough questions. Tell me something. Okay, this is a positive charge. This is a positive charge. I'm going to take my positive charge towards the positive charge. Okay. Do I give energy or do I lose energy? Or like, do I gain energy or do I lose energy? Yes. You're taking a positive charge towards a positive charge. Does your particle gain energy or lose energy? By the way, which energy am I talking about? Electric potential energy. Kinetic energy answer ulta. Okay. So this is gain. Now, what if I want to take my positive charge that way? Yeah, because it's naturally going. It's losing all the potential it has. It's speeding up in the process. Okay, so yeah, that's mainly the criteria. So there এটা নিয়ে অনেক question হবে, তার জন্য I make this table, especially in the non-uniform field. Okay, so I'll just give you the definitions of the field that you copy right now. Yes, due to charge or anything. Because non-uniform here কোনো definition নাই. আমরা a particular non-uniform শিখি, which one? Radial, but non-uniform anything. Any kind of scenario is a non-uniform field. Our uniform field is only possible under one circumstance, where you have two parallel plates and the parallel plates have evenly charged distribution. Yes. I'm doing just headaches. তোমার রেজাল্টের সাথে মেল করে দেয় the check scripts. করতেই পারে, it's very possible. or even worse, this randomly হচ্ছে number দিচ্ছে based on your previous performances. They have done that before. তার জন্য রিচেক গুলোকে খুবই হচ্ছিল কমপ্লিকেটেড প্রসেস রাখে। তোমার ক্লেরিক্যাল রিচেক আছে, এই রিচেক, ওই রিচেক, ফাইনালি তুমি রিচেক করে পেপার যদি চাও, it's like 3 times the cost of actually giving the exam. No one goes for it. But edXL backfire করছে এটা। edXL তো পেপার যখন ফেরত দেয়, you can clearly see that they're not doing a good job, right? And then if you go for a recheck, ওরা একই জিনিসই করে তারপর রিচেকে দেখা যায় যে হচ্ছে মার্ক বাড়ায় দেয় না। They will somehow just manage to change somewhere else something else and say যে না তুমি সেমই পাচ্ছ। O levels 3. Math, pure math, full 99 ছিল, but it was apparently the highest. I mean, physics, there's math. It took math bhalo lage amar. Once the numbers disappear, it turns into alphabets. I hate it. Yeah, my favorite subject was actually biology. Random, but yeah. But A levels in A because I've heard stories that you know I take it in A levels. I tried locally. Yeah, I think so. Maybe hindsight. শেষ। তোমাদের SAT this time was it computer based? তোমাদের Cambridge edXL at least start করছে computer based করে ফেলবে। So 2030 মধ্যে the exams are no more going to be written exams. It's all computer based testing. So check করার কোনো problem নেই। I'm sure some of the papers for it, কারণ edXL কিন্তু there's no tick marks. So a check paper যখন ফেরত দেয় is just how much you got. There's no like a person writing anything, no tick or anything. It's just পাশে box এর মধ্যে হচ্ছে computer type করে ওটা করে। But I think AI করে না because addition mistake হয় নাই। So probably এখন মানুষ করে। That sounds very depressing. না future আছে কেন থাকবে না, ওরা অন্য কিছু করে। না না, so AI use করা তো আর computer science এর স্টুডেন্টের কাজ না। No, so you'll have to come up with something new. You know, that's smarter AI or something that can stop AI. That's actually the problem in the future. মানে এখন এত হচ্ছে couple of years মধ্যে এত littered হয়ে গেছে the internet with AI content, right? What's real, what's fake তো বুঝতে যাচ্ছে না। So you have to come up with something that can outsmart the AI. So smarter AI. এআই? হ্যাঁ, পারে তো। হ্যাঁ, মানে it's called machine learning. You're training it, right? So train করতে করতে একটা পয়েন্টে তো ও সবই পারবে। And right now যে AI টা দেখতেছো, it's in the making for 10 years. ওকে শিখায় ও ইন্টারনেট ঘাটছে 10 বছর ধরে শিখার জন্য। ফাইনালি এই স্টেজে আসছে। So এখন কিন্তু প্রত্যেকদিন আপডেট হয়। So একটা point is getting smarter and smarter. Or so the worry is that either it will become too smart or it will become very dumb. Because হচ্ছে ইন্টারনেট তো littered with misinformation. So এখন যেমন AI কিছু ধরো সার্চ করি, I have tried physics-এরই, যে একটা wrong answer দিল। তারপর আমি ওকে বলি this is wrong. So oh yes, of course it's wrong. তারপর he does the math again and does it wrong again. মানে ওর বুঝে না what's right, what's wrong. So ওরকমও হইতে পারে। We're at like a crossroad. Either it gets better or it gets like it becomes a meme. Then no one really uses AI anymore. মানে ও কিরে করেছিল? হ্যাঁ। Oh, হ্যাঁ, আর এখন তো হচ্ছে there's a better one. You just take picture of a math, they'll solve it for you. হ্যাঁ, বাট ওইটা করতে গিয়ে অনেক মিস্টেক হয়, বিকজ তোমাদের যে কোয়েশ্চেন গুলো এখানে থাকে, আই ট্রাইড উইথ দেম, অ্যান্সার ম্যাচ করে না। পরে আই এম কনফিউজ, লাইক হ্যাভ আই বি ডুইং সামথিং রং অর নট। পরে দেখি না সে ভুল করে, এন্ড পরে বললে হচ্ছে অ্যাকনলেজ করে, বাট তার আগে কিন্তু খুব কনফিডেন্ট ছিল যে দিস ইজ দি অ্যান্সার। Okay, so this is the uniform field potential. They just একটা ছোট জিনিস বাকি আছে, ওটা নেক্সট ক্লাসে করব, the graphs of this topic. Okay, so ওটা করলে we can start capacitors. হ্যাঁ, পেন্ডিং আছে, এই উইকে করে দেবো।